Hi ladies, we're here for moles part 3 and what we're going to focus on is this section 9.9 in your workbooks because it's the one that's it's taken from exam questions and is probably most applicable to what you're going to be doing in terms of June in your Leaving Cert. Okay, so I'm hoping that at this stage, if you're on moles part 3, that you've watched moles part 1, you've watched moles part 2, and that you're okay with the examples in your workbook so far. Okay, so first of all, 9.9a, they're asking us, it's from a Leaving Cert question, define a mole of a substance. So a mole of a substance, substance is the amount which contains that special Avogadro's number 6 by 10 to the 23 particles. Okay, so that is your definition for a mole there, okay? It's the amount of substance that contains 6 by 10 to the 23 particles, okay? So that's your A, okay? Part B. Now, part B, let's have a little look at this question. So how many moles of aluminium are there in 3 moles of Al2SO4 by 3, okay? So that's aluminium sulfate, all right? So 3 moles of Al2SO4 by 3, okay, so they want to know how many moles, so Al3 plus how many moles. Okay, so if you've got 3 moles of aluminium sulfate, okay, and that each aluminium sulfate molecule contains 2 aluminiums, okay, that means you've got 6 moles of aluminium. Okay, does that make sense? So you've got 3 moles over all of this. If you've got 2 of these, Al2, 2 aluminiums per molecule, that means you've got 6 moles of aluminium. All right, so your answer here, there's no real calculations to be done. 6 moles. Okay, is that all right? Okay, that's a little bit kind of different than what we've done before. C, again, it's a very similar question to that one, again from a Leaving Cert question. How many sulfite ions, SO3 2-, are present in 2.1 grams of anhydrous sodium sulfite? Okay, so again, so part C, so Na2SO3. Okay, so it says you've got 2.1 grams of that. Okay, and they want to know number of moles of SO3 2-. Okay, so first of all, we're going to have to work out the number of moles of our molecule here. Here in this question, they were quite nice. They gave you the number of moles of our aluminium sulfate. Here we're going to have to work that out, okay? So again, we're referring back to our mass moles AOR triangle. So mass moles AOR or MOR here, okay? So if you're looking for a number of moles, cover over moles in your triangle, it's going to be your mass divided by your molecular weight of your sodium sulfite, okay? So that is going to be 2.1 grams divided by your mass of your sodium sulfite. So that is going to be, so it's Na2SO3, so it's 2 by 23, that's sodium, plus 32, which is sulfur, and 3 oxygens, which is 16. Our answer is 126, okay? So 126 divided into 2.1. Do that on my calculator here. So 2.1 divided by 126, and my answer is 0.016 recurring, so 0.17 moles. Okay, now let's look at the structure of our sodium sulfite here, okay? There is 1 sulfite molecule per sodium sulfite. So if we have 1 mole of sodium sulfite, we've got 1 mole of sulfite ions, okay? But this time we don't have 1 mole of this. We have 0.017 moles of our sodium sulfite. So therefore, our answer is, so SO3 2- ions is equal to 0.017 moles. It's the same. It's a 1-to-1 reaction because we have 1 of these in each molecule of that. Okay, so I'm hoping that is easy enough for you here, okay? Now, let's move on to part D. A little bit easier, I think, than those 2 examples. So part D, let's have a look at question D. How many atoms are there in 0.36 grams of magnesium? Again, another leaving cert question, but it's a little bit more straightforward. It's again, we're just using our mass, moles, AOR triangle, MOR triangle, okay? So mass, moles, AOR, or MOR, okay? So we are told, so 0.36 grams of Mg, and they want to know how many atoms there are. Okay, so we're going to have to work out first of all our number of moles, and then you're going to use our Avogadro's number. So let's work out our number of moles first. So cover over your moles on your triangle. Okay, so it's going to be our mass divided by our atomic weight of magnesium. So 0.36 grams divided by our magnesium, which is 24, has a mass 24. That will give us our number of moles. So put that against your calculator. So 0.36 divided by 24. That is going to be 0.015 moles. Okay, so that's how many moles you have, but we're being asked how many atoms. So you have to take that 0.015 moles and multiply that by our special number by 6 by 10 to the 23, our Avogadro's number. Okay, that will always be on the front of your exam papers. Okay, so by 6 exp 23. Okay, and our answer there is 9. Let me see if I do that again. So 0.015 by 6 exp 23. I'm getting 9 by 10 to the 21. Okay, that's what I'm getting there, all right? So there's your answer for that one there. Okay, now let's move on to the next one. What mass of magnesium contains the same number of atoms as 8 grams of calcium? Okay, so there's a number of steps we're going to have to work through here. Okay, so part E. Okay, so we're talking about a number of atoms in 8 grams of calcium, first of all. Okay, now remember, we've looked at numbers of atoms in the previous videos and also in the last part as well. So remember, we're going to have to work through a number of steps. We're first of all going to have to work through our number of moles in 8 grams of calcium. Then we're going to have to calculate that to numbers of atoms, and then we'll go back to the original question and ask look at what they're asking us to work out. Okay, so again, you're looking at your moles, so it's going to be your mass divided by your atomic weight of calcium. So 8 grams divided by your weight of calcium, which is 40. That will give us our number of moles. So 8 divided by 40, that is 0.2 moles. Multiply that by 6 by 10 to the 23 if we're looking at number of atoms. Okay. Let me see here for a second. I'm going to put my calculator down. Okay, never mind. Okay, so 0.2 by 6 exp 23. So your answer there is 1.2 by 10 to the 23 atoms. Okay, so that's how many atoms. Now let's have another look at this question. Now they're asking us what mass of magnesium contains the same number of atoms as 8 grams of calcium. Okay, so let's have a little look back here. Okay, so we're talking about how many moles of magnesium, what mass of magnesium. So we're looking for mass of magnesium contains 1.2 by 10 to the 23 atoms. Okay, so what we're going to have to do here is we're going to have to work backwards from this. Okay, so if our magnesium contains 1.2 by 10 to the 23 atoms, we're going to have to again divide that by 6 by 10 to the 23 to work out our number of moles of magnesium, and that's going to be easy because that's going to be the same as our number of moles of calcium. So that's going to be 0.2 moles. Okay, so 0.2 moles is their number of moles of magnesium, but they've asked us for the mass of magnesium. So remember, we go back to our triangle. So our mass of magnesium is going to be our moles multiplied by our atomic mass of magnesium. So it's going to be 0.2 multiplied by our mass of magnesium, which is 24. So so 0.2 by 24, and that is equal to 4.8 grams. That's your answer there. Okay, all right, so that was part E. We'll do one more and then I'll leave you guys to do the rest yourself, okay? So E, because we've done E, so obviously E, F. Okay, now F. How many moles of magnesium atoms are there in 0.2 grams of the metal? Okay, so again, this is easier than the last question. So let's have a little look at that. So how many moles of magnesium atoms? Okay, so 0.2 grams. Okay, and they're asking us for how many moles. So again, we have to refer back to our mass moles AOR triangle. So mass moles AOR. Okay, so if we're looking for a number of moles, it's going to be our mass divided by our atomic weight of our relative atomic mass of our magnesium. Okay, so it's going to be 0.2 divided by our mass of magnesium, which is 24. So 0.2 divided by 24. Okay, that is 8.3 by 10 to the minus 3. Okay, or that's the same thing as 0.0083 moles. Yeah, so that's what they're asking us there for F, okay? So that's our answer there. So girls, I'm hoping that you're starting to get the idea of how to convert between mass and moles and the hardest bit, which is probably converting to molecules. So I'm hoping you've given that a go. If there's any questions on any of those pages in your workbook that you want me to go over or you're not too sure of, please ask me. Or maybe if you find a moles question in the papers while you're doing questions that you find a little bit difficult, please contact me, girls. And a number of you have already, and I will get back to you with how to work that out. Thanks, girls.